This is a video on using the chain rule and finding the equation of the tangent line. The question states, find the equation of the tangent line to y equals the cosine squared of x at the point pi over 4, 1/2. So to find the equation of the tangent line, we have a point, we need the slope, and the slope is the derivative evaluated at the point. So let's first find the derivative, and to do that we have the cosine squared of x. It's easier to write the cosine squared of x in another form, and that's that the cosine squared of x is the same as the cosine of x quantity squared. And now we can use the chain rule to find the derivative. The derivative of the inside, derivative of the cosine of x, is negative the sine of x. And the derivative of the square function is 2 times what's inside. So I get my derivative is negative the sine of x times 2 times cosine of x. We can rewrite this as negative 2 times sine of x cosine of x. And I do that. And now that we have the derivative, we can find the slope of the tangent line by plugging in pi over 4 for x. And I do that. And then remember the sine of pi over 4 is 1 over root 2. And the cosine of pi over 4 is also 1 over root 2. And 1 over root 2 times 1 over root 2 is 1 over root 2 squared, or 1/2. 2 times 1/2 is 1. So I get from my slope of the tangent line negative 1. And now I can just finish up by using the point slope form for the equation of a line. I have my slope, which is negative 1. I have my point, which is pi over 4, 1/2. So remember that point slope form is y minus y1 equals mx minus x1. So in particular, I have y minus my y-coordinate, 1/2, equals m. M is our slope, which was the derivative, which is negative 1, times x minus my x1, and the x-coordinate is pi over 4. So now I just clean it up a bit, multiply the negative 1 through, and I get negative x. A negative 1 times a negative is positive, pi over 4. And then finally, I add 1/2 to both sides, and I get my final answer. The equation of the tangent line is y equals negative x plus pi over 4 plus 1/2. And I'm done with the problem.